Welcome to this talk called 10 Things That You Already Knew About Architecting Cloud Data Platforms, with a subtitle of Another Tribute to Stupid Tax. For those of you that are aware, this is my second 10 Things talk that I've put together. The previous one was called 10 Things That You Already Knew About SSIS. Right, so quick about me. My name is Andreas Bergstedt. I've got just over 22 years in the IT industry. Started off as a counter technician, and I'm currently working as an Azure Data Platform Solutions Architect. I'm an active speaker and participant in the SQL Server user groups and the PaaS organizations. I've got a strong focus on building practical BI solution, and I focus on or try to take a lot have a logical approach to solving business and operational problems. One of my technology mottos is that if it can't be automated, it's not worthwhile doing. If you want to read through my blog, you can go to blog.bi360.ml. Follow me on Twitter at Andreas Bergstedt, or send me an email at andreas@bi360.ml. Right. Today's session is broken up as follows. We're going to have a quick introduction and explanation and talk about stupid tax. After that, we go into the 10 things that you should already know or that you already know, which is basic learning and resistance to change. And then in the normal session, there would be a 10-minute Q&A session. But since this is a recorded talk, there won't be any Q&A. So, stupid tax. What is stupid tax and who pays it? So, stupid tax is an unnecessarily and generally avoidable taxations upon one's regular habits. In other words, you go and buy something on your credit card, you pay additional costs, you borrow money, you pay additional cost. You do something that you know you shouldn't do, and there's consequences to it. So stupid tax is just it's known additional taxation on your regular habits. So for a bit of comic relief, we are going to watch a quick music video by Lonely Island called Throw It on the Ground that I feel illustrates stupid tax brilliantly. Okay, so I'm not going to show this music video because it's just going to end up in a copyright strike. And it's going to prevent this video or tutorial from being uploaded. So I'm just going to tell you about it. So if you want to see the video, which is a great play on irony around not learning lessons, then please go and search for Lonely Island, Threw It on the Ground. It's an awesome parody video. And yeah, um, feel free to go onto YouTube and look it up. Right, so this gentleman clearly was going to pay stupid tax for the rest of his life. He clearly didn't understand what he was doing wrong. But anyway, this was a very comical way of illustrating stupid tax, and I hope you enjoyed it. So let's jump into it. So the first slide is called CI/CD doesn't fit our operational model. We're just going to do a lift and shift. So this is a slide that sort of talks to when you're doing a cloud migration, or when specifically when you're doing a cloud migration. So as a developer or as a database admin or as a SQL engineer, you may feel that there's a lot of effort moving to the cloud, and there are all these tools like you know SSIS integrated or SSIS runtimes in Azure Data Factory that allows you to publish your SSIS packages and run them, so you don't have to redevelop anything. Yeah, that kind of that can make you lazy. Other things is that you're not looking at patterns and how they work in the cloud versus in the enterprise or in your data center. So first, first thing is think cloud native. So when you're doing a cloud migration, you shouldn't be doing a sort of a PTV or a VM migration and get a whole bunch of infrastructure as a service assets or IaaS assets. You should look for PaaS and SaaS solutions that are cloud native. Look for data lake storage concepts that will fit. Look for cloud database engines, relational and non-relational database engines. Look at how you can leverage open source technologies, Spark, Hadoop, those kind of techs to sort of serve your cloud data platform, because ultimately you'll get a better um, you'll get a better and more efficient and effective result if you do that. The second thing is plan for redevelopment. So understand that even though you might be migrating a SQL Server database or a set of application databases and consolidating them into an Azure SQL data warehouse or into a leaner or newer SQL database or into a managed instance estate, understand that there are certain things about your target technology that will require redevelopment, like um, partition structures that are not supported, cluster keys that are not supported in Azure SQL Data Warehouse. Look at different, query plans don't function the way they do. Optimization works a little bit differently. The only wild card here is, I guess, SQL Server Managed Instance that is pretty much sort of 99.9% representation of an IS asset. There are certain things you can't do, like file system. You can't inject DLLs. There are a couple of things you can't do. But just plan that there are going to be technology roadblocks that need to be solved. And sometimes the solution might look very different. It might not be we're just going to use an isNull function instead of a concat function, or whatever. There might be something that needs to be redeveloped, and you might find that being using Databricks for cleansing activities instead of your custom CLRs that you were building, or DLLs that you were injecting in your custom code in your on-prem SQL estate. So that's that. The other thing when you're doing a migration, you should think about your sort of data buckets or data boundaries, and understanding your recovery points. So you might have one process that only deals with one data boundary, being extract and land, um, you know, or extract and load, and then you have another one that does load and stage, and then you have another one that does from stage and transform. So your data boundaries become different, but we'll talk about that later. But these are things that you should think about and understand that lift and shift is your last it's your last resort. You should never go for a lift and shift solution or migration. You should always plan for redevelopment. Go cloud native. It will be the best. So next slide is sort of back to the future inspired. Roads, where we're going, we don't need roads. So assuming that you've seen Back to the Future as end scene, or the second one's opening scene. Um, you know, Many people think, okay, well, I'm going into public clouds. I don't have to worry about what my infrastructure looks like. I don't have to worry about boundaries. I'm just going to set up some rules, and hey, it's all access controlled, and someone else is worrying about security here. Um, no, you should treat your cloud estate, your public cloud estate, as your private network. Think about it. Um, you always look after and safeguard and put boundaries around your data centers and your private corporate networks. So why should your public cloud be any different? It's always, you must always think about these things. And deploy VNets, deploy VPNs into this, site-to-site VPNs or express routes, dedicated circuits, like make sure that your assets are as secured as possible. And then this slide is quite funny. Sure, I trust Azure services. So speaking of security, when you're locking down your SQL Server estate, it's great that you can lock down your assets, but what you're gonna have to think about is also that you will have assets that you can't lock down only to your estate, or that needs public interface. So typical example is um, Azure analysis services, right? You often want that to be publicly accessible, and the reason, well, for one of two reasons. Publicly accessible from Power BI. So Power BI need to query it. So this little switch here from in Azure is valid for this. So on the firewall settings or the firewall rules settings on Azure Analysis Services, you would have, allow access to Azure services enabled, because Power BI is an Azure asset and or service, and it needs to connect to this resource, right? But it brings a challenge. It means every single Azure service, including VMs, and they don't have to be in your subscription. So this can be, or in your tenant. It can be, or not even your region. This can be someone spinning up a VM somewhere as a jump box, and then going trawling the entire Azure subnet, trying to find open and unsecured access to, or unsecured assets like SQL databases, storage accounts, and a whole bunch of them. So this is important to think about. It's okay to enable this as long as you have documented it, and in your sort of in your security policies and plans that this actually is catered for, so you know the exposure and know the risks. But yeah, just because this says Azure services, don't think that this is locked down only to PaaS and Azure SaaS services like Power BI, Azure analysis services, Stream Analytics or anything. Don't think that this is locked down to Azure only native Azure services from Microsoft. This is VMs that are spun up in tenants all over the world. So the next slide talks a bit about persisting data. So I don't want to persist data. Storage is expensive, and here we're looking at a slide where your total monthly compute cost for storage is 20% of your entire bill. Now, that's not a lot. 20% of your entire bill. You're okay to persist data, and this is a real life cost scenario from one of my uh, development estates or tenants, and this we were talking about terabytes, hundreds of terabytes of data here. This is not a small storage account, and the compute resources are 2 to 3 times more expensive than the actual storage account. So storing data, as long as you do have a good storage strategy and you follow some store once guidelines and never store data unprocessed into location, then that is good. And think about it. You can uh, have consumption patterns that will allow you to save on your compute resources by scaling down and switching off. Also spending data warehouses or analysis services instance outside of processing and operational hours and SLA hours. So, but storage is one of your cheapest resources. Here's another one talking about adopting. So, yeah, here's an ETL developer that's trying to sort of go to cloud, and he goes, "Oh no, ETL is still my go-to data movement pattern, and I'm just gonna, yeah, I'm gonna grab some stuff, I'm gonna transform it in flight, and I'm gonna, you know, load it into a data warehouse." Now, in-flight transformations are slow in cloud services and unreliable. Um, they are getting better in the likes of Azure Data Factory data flows, which allows for Spark instances or not Spark, um, Databricks instances to be spun up and run some in-memory transformations. But again, this is it costs a little bit of money to run this, and it shouldn't be your de facto pattern. You should rather look at setting up some data boundaries. You have a source system or data sources. You should have your Azure Data Factory going collecting that data. This is, if you look below, this is my typical go-to pattern. I take data from a source system that's read by config or from a config table into parameters in generic data factory pipelines. I then store everything in walk files in blob store. I then traditionally, depending on the size, I do a poly-based transaction from SQL, Azure SQL Data Warehouse on the either blob store or on I've been starting to use Azure Data Lake Storage V2 or Gen 2 more and more commonly or frequently. So I go and I run polybase ingestion from that and into a staging area, and then from there process that into a live table and move that forward. So this is my go-to pattern. It is stable. It has data boundaries. It's clear defined. Lift and load, or extract and load, or extract and land, and then um, lift and stage, and then stage to live or stage to process. And it's a very effective pattern. I can have the initial uh, sort of extract and land process run really, really frequently, and then have my batchy data warehouse process run, I don't know, once an hour, once every second hour. And that this pattern is really, really efficient. Yeah. So again, in-flight, stay away from in-flight transformations, leverage on-demand scale, so MPP processing, um, which will be more efficient in the cloud, and then think about data boundaries, structure things. Um, and also that means that you can separate processing, so you don't have to have one rely on the other. Right, the next thing talks about cost of running these Azure environments. So this one's £30,000 a year for my production environment. What about my dev and test environment? What are they going to cost? So again, storage is cheap. Think DevOps. That's the first thing I'm going to say. So if you build DevOps pipelines, it's easy for you to alter code and run builds and then run those in deployments where you can automate a stand-up of a dev environment or a test environment, let it deploy the code, let it run a couple of process cycles for your regression testing and your unit testing, ship that into your UAT environment, run the same process, and then allow that UAT to be exposed for the customer. Shut down your environments using automation so that they stand down once things have been tested or after a certain amount of inactivity. So that means that your expensive compute resources in your environment process your data. They will be very much on demand, but not run all the times for your dev and test. And then, storage is cheap. Don't worry too much about storage. As long as you handle your data storage and you manage it, and you don't grow petabytes of data, you should be okay with storage accounts. And this example where I got this 30K figure for prod environment, the dev and test combined, or dev and UAT combined cost was roughly about 5 grand. on an average annual cycle, um, because it just stood down. The only thing they paid for was storage. And again, in your dev environment, storage is tiny. In your test, storage will probably be a little bit more because you will have some form of production data in your test or your UAT. Um, but it's not going to be the same as your production loads. So, you know, it doesn't, if you develop or your cloud data platform correctly and you have the right strategy in architecting it, you're not going to get killed by cost in your dev and test environment. Cool. Here's one that talks about security. So, yeah, my developers have all the passwords and I know I can trust them. So, well, first thing is, you should always try to use key vaults. Key vaults are better to store. You can secure endpoints or you can allow access to key vault resources for secured endpoints like Data Factory, which means that you should have different key vaults for different environments. You have a key vault for your dev environment, and you should run this through, which key vault you're connecting to. All those connection strings should be parameterized in Data Factory, for instance. But it means that you have a certain set of credentials that you can trust your developers with because they have no real value. There's no production data and they're isolated. Um, but by using config for parameters, they can write code and that is then generic, so that when it gets deployed in your production environment, just picks up the key config from or the security tokens and the passwords and everything from the key vault, from the production environment, and everything just runs smooth. And no one needs to know any passwords. You can change your passwords then through system, rotational random passwords that gets run through the key vault APIs and that on a monthly basis or quarterly basis without even have to worry about touching anything. The other thing is about securing assets. So um, this goes back to your enterprise. If you have someone that leaves, so a developer that leaves, they shouldn't be able to touch your assets once they left your corporate network. Yeah, VPN access should be dead. Their account should be locked out, suspended, whatever, and they shouldn't be able to even touch your front end. Um, yeah, but that just goes to show. This slide talks about serverless. So the serverless seems to be a bit of a buzzword with a lot of compute sort of or cloud compute providers. So we have Athena and the likes of that. In AWS, you have HD Insight with USQL um, in Azure. You got Azure Functions that sort of do serverless just data processing, where you can do data processing activities with Azure Functions, or Lambdas in AWS. But they all sort of have their place. They won't solve all your compute problems, um, because but they do have their place. Uh, you know, as your functions, they're there for event-driven data processing. File drops into blob store, data lake store. Do something with that file. Trigger an event, process something. Um, you know, run some um, USQL code on your Hive clusters, whatever. Yeah. But serverless won't solve all your problems. Sooner or later, you are going to want to have compute power, either a SQL data engine, Databricks, or to the like of something like that. Then here's another slide that talks about NoSQL. So NoSQL, a lot of MongoDB people will say NoSQL is a one-size-fits-all for all data platforms. In other words, I'm just going to spin up this Cosmos DB. I've got my graph database for all my identity and periphery data. I've got my table store for all my key value pairs, and obviously I have my MongoDB for all my JSON data. So that's great. They full, let's not forget that all the effort that's gone before in terms of building analytical data stores, and relational database engines, and data warehouses. We need to understand that those ones are there for a reason. No SQL is not going to solve every single problem. If we change all our data loads to store in MongoDB as JSON, um, it's not going to be efficient to traverse that data and run massive, real-time sort of compute transactions to, it's not going to be efficient. And it's not going to be, besides that, it's not going to be performant. It's also going to cost you a lot in running those transactions. And also remember that everything has a use case. So JSON semi-structured data is really, really good for application style data, where we're looking at some form of unique identifier that we're querying, and then bringing back properties about that unique identifier, so that something that would be served up in a web interface. JSON is really good for that, or NoSQL or MongoDB is really good for that sort of application databases, um, modern web app databases. So let's just remember that there's use cases. So um, here's another one. This talks about resistance to trying to find the generic data flows or the repeatable patterns. So the title here is all our data pipelines are bespoke and we can't build any generic data flows. So this is typical resistance when moving to cloud patterns, where SQL developer and ETL developer has built all of these SIS packages, and he goes and he looks at them and he says, no, everything is generic. If you have clear defined boundaries, and like how you extract data and land it, and then from landing it, how you stage it, and then from stage it, how you process it into live, you can have, I guarantee that any ETL data flow can at least have, as an absolute minimum, 20% of it is generic and has commonality with every single other data flow in your entire ETL project. So you could generalize or create a generic config that has a minimum of 20% automation or repeatability throughout your entire project. So think about those. Remember defined process boundaries and data boundaries. That will help you. And then look at your process, or your entire process end to end. You'll identify these. You'll see. Okay, well, I've got 10 source systems. So every source system has a different connection attribute, but the configuration of um, the data pipeline, you'll find, okay, so I've got 10 Oracle databases that are connected. Well, so the database names, they're all sitting in the same Oracle clusters, but there's 10 different database systems or database application databases. But you can do one generic data flow, parameterize that, read the parameters through config, and then just, off you go. That entire staging process can then be made generic. So with that, we would normally go into a question section, but as this is a recorded or pre-recorded sort of webinar, this won't go into that. If you want to go through my blog, it is not the most active blog, but it does have some interesting material there. You can do so by visiting blog.bi360.ml. You can follow me on Twitter. I sometimes say interesting things and do announcements. You can send me an email if you have any questions, or you can go through my GitHub repo and go through other presentations that I've done for SQL Saturdays. I've got some source code there. I've got a few proof of concepts on row-level security, etc., etc. So this slide deck is going up there with links to the video. Thank you very much for attending. And if you want to see more of this kind of content, don't forget to like and subscribe. Bye.